time, we added on a level of substructure to what we had so far. We had two levels before. We had the level that is so obvious to us in gravitation, which is the acceleration, gravitational acceleration, which we know as the connection between the time dimension and the spatial dimensions. We had a level above that, which is the Riemann curvature, which is how two neighboring geodesic world lines behave with respect to each other. And we added a level now, two levels below the Riemann curvature, one level below the connection curvature, and that was the metric. What we did is we said we have two groups of three levels. We had now a three-tiered structure to gravity. It's very beautiful. We started out with the gravitational acceleration, right, which we found is the connection curvature. The gravitational acceleration we found was a little bit not the best, reliable indicator, because when you're free fall, it vanishes. We found that the real thing was a tidal acceleration above it. And we found there were more components, or three components at least, to the tidal acceleration, or maybe 9 components in a general case, right? You have this array. And they're all, though, derivable from the three components of the acceleration. And parallel to it, we call the tidal accelerations, we called that Riemann curvatures. Okay, so we had the tidal acceleration, the gravitational acceleration. Parallel to it, we had the Riemann curvatures and the connection curvatures. Now we found that in this side, tidal gravitational acceleration potential, what's the geometric thing in space-time that's going to be here? We had Riemann curvatures of space-time. We had connection curvatures of space-time, which is the curvature of the geodesic of the curved space-time. What is the thing that's going to be underneath it? The space-time quantity. Okay, it'll be, again, a three-tiered structure. Again, we have these three levels. We started out with acceleration. We went one level up to the tidal acceleration. Then we went one level down to the potential. In the same way, parallel, we had the connection curvature of the world line, which is really the curvature of the geodesics of a curved spacetime. We went one level up to find the curvature of the spacetime, which is measured by the deviation of neighboring geodesics, not one solitary geodesic. And we went one level down to find, instead of a connection curvature, to find a metric, which tells us about the curvature of the spacetime. And we also know how these are related. This is like the derivative of that one. Okay? So you have this, again, very, very beautiful three-part structure on both sides, and we know exactly how they're related to each other, and we hope naively, and in fact it turns out in surprisingly exact way, that these two columns of three structures are not only kind of parallel, but they actually give you the same number, the same formula when you solve the problems, which hopefully we'll be able to do also next time.